Hi everyone, we're going to find the domain of these two logarithmic functions. They're both logs, so we're using this, and I consider this the big X here. So this whole thing has to be positive. This whole quantity has to be positive. This, whatever this quantity is, has to be positive. So let's get started. We have this first one, and that means, like I said before, this whole quantity, it requires it to be positive. Doing the wrong one. All right. So this x plus 1 divided by x must be positive. All right. And also when you're looking at this, and I'm going to call this p, this part inside here, p of x equals x plus 1 divided by x. It is undefined when it's 0 or undefined when x is negative 1. So it's undefined when x is 0. And if you plug in negative 1, you're going to get negative. So if I do x equals negative 1. So I plug in negative 1 here, I get negative 1 plus 1 divided by negative 1. And that's going to be 0. And we can't have 0 because it has to be greater than 0. So these are two critical numbers. So let's see what's going on either side of 0 and 1. So I'm going to write down 0 or negative 1. 0 and negative 1. So if I plug in, I'm going to plug in here negative 2, negative 1/2, and I'll plug in 1 here. So let's do the easy one. If we plug in 1 for this portion, I'm going to get p of 1 equals 1 plus 1 divided by 1, which is 2. This is positive. It's greater than 0. So this is positive. If I plug in negative 1/2, I'm going to get p of negative 1/2 equals negative 1/2 plus 1 divided by negative 1/2. And what this is going to be a positive divided by negative. Well, that's going to be negative. So this part right here is negative. And, the part that's negative is right in here. And let's test negative 2. So if we're going, let's see what color I'm going to use. I'll use this color. So let's test negative 2. So if you plug in negative 2, p of negative 2 equals negative 2 plus 1 divided by negative 2. Well, this is going to be a negative divided by negative, which is positive. So this part's positive. So your domain is going to be, for G or F, is going to be all real numbers. Okay, but we want positive and positive. And our critical values were negative 1 and 0. So basically, x could be less than negative 1. It can't equal it. Or x has to be greater than 0. All right? Sometimes you can just do this mentally, just by looking at it. Okay, let's try the next one. All right. So the first thing, this is your big X. This big X, which is x divided by x minus 1, has to be positive. It can't be 0. So let's let this part here be our p. So p of x equals x divided by x minus 1. Well, our critical values are going to be x equals 0. If you have 0, that will be 0 over negative 1. And this has to be greater than 0. So, and also it's undefined at x equals 1. So let's test what's going on. Let me try to make this a little neater. So let's test what's going on at 0 to 1. So in here I'll put 1/2. On this side I'll put 2. And on this side, I'm going to put -1. So we want to know what's going on to the left of 0, to the right of 1, and between 0 and 1. So let's test it out. If we plug in P of -1, we get -1 over -1 minus 1. That's going to be a negative divided by a negative, which is positive. So this area in here is positive. Now let's test 1/2. If you test 1/2, you're going to get 1/2 divided by 1/2 minus 1. You don't really have to do the math. You just know the numerator is positive, denominator is negative, so that's going to be negative when you divide. So this part in the middle between 0 and 1 is negative. We have to discard that. And then let's plug in 2. So P of 2 is going to be 2 divided by 2 minus 1, which would be a positive divided by a positive, and that is positive. So this is positive. And we just want positive values. Look at that again. So our domain for this is all real numbers such that x has to be less than 0. We're looking at this part right in here. Or x is greater than 1. And that's this part right in here. All right. And that's it. Thank you. Have a nice day. Bye-bye.